Well, this is an interesting sequence of numbers, isn't it? Here in exercise 3, we're given a sequence. We're told that it's arithmetic, and we're asked to find D. Now, in this case, the D that I mean is this D. I know I've been using D as the difference between consecutive numbers, but in this case, it's this D right here that we're asked to find. So, but we're just given the first number, the last number, and we also know the number of numbers because we can um, count them. The numbers in the middle here are represented by letters, but they represent numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8 numbers in this list. Okay, so let's just start with what we know. We know that for any arithmetic sequence, the nth term is given by the first term plus n minus 1 times the difference. Now, in this case, I know I've been using D in the past, but I don't want us to get confused between this D and the D I use for difference. So I'm actually going to use a different letter for the difference between consecutive numbers. I'm going to use a Greek letter, delta, which looks like a triangle. That's supposed to be a triangle. Delta is often used by mathematicians and scientists to represent a difference. Okay, and it's just a Greek letter. So instead of using these Roman letters, we'll use a Greek letter. All right. So, so we know that. So let's see if we can plug in the last number here. So we know that 28 is equal to 7 plus n minus 1. Okay, so let's label these. This is A1, A2, A3, A4. The number we're looking for is A5, A6, A7, A8. Okay, so we know that the 8th number in the sequence is 28. So that's equal to the first number plus n minus 1, so that's 8 minus 1 times the difference, and I'll use delta. So we can actually solve for delta, right? If we subtract 7 from both sides, we can get rid of, this becomes 0, so we'll get 21 is equal to 8 minus 1 is 7, 7 delta, and then I can divide both sides by 7 to get delta by itself, and I end up with 3 is equal to delta. Right? Okay, so our common difference between numbers is just 3. And once we have that, we can figure out any number in the sequence. So the number we're looking for is actually A5, which is D, what I call D. But don't get confused between this D and the common difference. So A5 would be equal to A1, which is 7, plus 5 minus 1 times delta, which is 3. So we can just compute that, right? We get 7, let's see, this becomes 4, so this is 12 plus 7, so that's equal to 19. Alright, so D, the number we're looking for, is 19. Now the other way we could look at it too, since we know that the common difference is 3, we can just add, start with 7 and add 3. So we could go 10, 13, 16, 19. And we get the same answer. So there you go.